9.6 is titled Rationalizing Radical Expressions. So rationalizing a denominator is the process of clearing radicals from the denominator of a fraction, because a fraction is not considered simplified if it has a radical in it. So we're going to start off with monomial denominators, single term. What we're going to do is we're going to multiply by a value which will result in a perfect radical in the denominator, and then to keep the fraction balanced, we multiply by that same value in the numerator. So we have, for letter A, 1 over the square root of 5. So to make a perfect square, I need to multiply it by the square root of 5, because that's going to make the square root of 25. So when it's square roots, it's pretty easy, because you just multiply by whatever that denominator is in both the numerator and denominator, and then you simplify it, and we get the square root of 5 over 5, which is as simplified as it gets, because the numerator is a radical over the 5. So it's not the same as the 5 on the bottom, they don't cancel. For letter B, I have the square root of 32. Okay, square root of 32, that simplifies. So before I talk about rationalizing, I actually want to simplify it first. So it's actually 4 square root of 2. So what I'm going to multiply by is the square root of 2. Because square root of 2 is what's left in the radical. So I need to multiply by whatever radical I have. So when I multiply across the top, I get the square root of 6. And when I multiply across the bottom, I have 4 square root of 2 times square root of 2, which is the square root of 4. So I have square root of 6 over 4 times 2, and the square root of 6 over 8. Part C, my radical is the square root of 5x. So that's what I'm going to multiply in both the numerator and denominator. So in the denominator, the 2 is in the front still, and then I have 25x squared. And the square root of 25x squared is just 5x. So I end up with 3 square root of 5x over 10x. All right, so what do I do if it's not a square root? Okay, if it's a cube root, I have to multiply it by the cube root to make a perfect cube. Well, if it's a perfect cube, that means its exponent is 3. So here I have 2 to the first. If I want to make a perfect cube, I need 2 squared. Because 2 to the first with 2 squared makes 2 to the third. And then the cube root of 2 to the third is just 2. In the numerator, I just make it 2 squared into a 4. So on letter E, I'm going to first start out by splitting this up. But then what I want to do is I want to, well, there's a couple of approaches. So if I wanted to do it like letter D, I would be multiplying by 12 to the second power. So let's try that. The reason I'm doing 12 to the second is because 12 to the first plus 12 times 12 to the second, we add the exponents and we get 12 to the third. So the denominator is the cube root of 12 to the third. The numerator, the cube root of 5 times 12 squared. So the denominator is just 12. The numerator That's 5 times 144. I don't have that written down, so let's take 144 times 5 real quick to get 720. Now I'm looking to see, do I know a perfect cube that goes into 720? Well, I know that 8 goes into 72, so 8's also going to go into 720. And since there's a 0 on the end, it's going to be 90 instead of 9. So I have 2, cube root of 90 over 12. The 2 and the 12 simplify. So I have the cube root of 90 over 6. So the key to these problems is making the denominator perfect. To do that, I need to make my exponent match my index. So on letter F, I need my 2 to be to the 4th power. And I need my z to be to the 4th power. So to make that happen, I need 2 to the 3rd z squared. And whatever you put on the bottom, you put the same thing on the top. Then we get 8z to the 3rd for the numerator, and the denominator, the exponent of 4 with an index of 4, what they're doing essentially is canceling. So we have just 2z. And then 10 over 2 is 5. So I have 5 times the 4th root of 8z squared. Oops, don't know how that turned into 3 squared over z. All right, we'll take a little pause here in this section and come back in the next video with the rest of it.